guys, in this video I'm going to show you how to answer circular measure exam questions. So in the first part of this question we have to work out the perimeter of the shaded region here. So I can see that the perimeter consists of three sides, okay, this straight edge here, DE, the arc length DC and the arc length EC, okay? So if we want to work out the arc length of a sector, okay, here and here, we need to use this formula over here, r theta. So to work out the arc length, you have to multiply the radius of a sector with the angle theta, okay? And the angle has to be measured in radians when you do this calculation. So to be able to work out the arc length, we have to know the angles. And at the moment, we haven't been given any angles in the question. But we do know that this is a right angled triangle. Okay, we know the length of the hypotenuse of the triangle, 5 plus 8, which is 13. And we also know that this length here is 5, because the radius of the smaller circle is 5. So because we have two lengths in a right angled triangle, we can work out this angle here and afterwards this one, okay? So let's start by working out this one. I'm going to call it theta 1. Okay, so if we're working out this angle, we can see that we've got the adjacent side and the hypotenuse side. So if we're using the adjacent and the hypotenuse, we know that cos theta is equal to 5 over 13, okay, adjacent over hypotenuse. So if you're trying to solve this equation to work out the value of theta, you would type into your calculator cos minus 1 of 5/13, and it will give you, and remember your calculator has to be set in radians when you do this calculation, 1.17600 and so on, okay? So that's the angle here, okay, for this sector in the smaller circle. Now from here, we can work out the arc length of this sector, okay, so the distance here of the curved part in the sector. So remember, to work out arc length, you multiply the radius with the angle theta. So the radius in the smaller circle is 5, and the angle theta in radians we just worked out here. So leave that answer on your screen from earlier, multiply it with 5, and you should get 5.8800 and so on, okay? So that is the first length in finding the perimeter of the shaded region, okay? Next we have to do the same thing but for this sector here in the larger circle, okay? So we need to work out this angle here, theta 2, okay? And this time I can see I know the length of the opposite side in the triangle and the hypotenuse. So this time I'm going to use sine theta. Okay, and remember it's equal to the opposite length, 5, over the hypotenuse, which is 13. And if you solve this equation to find theta, you type into your calculator sine minus 1 of 5/13. And when you do that, you get 0.39479 and so on. Okay, so that is the angle of this sector here. Okay, so the arc length is found using that formula from before. Okay, we have to multiply the radius, and this time the radius is 8 centimeters. And when we multiply that with the angle that we just worked out, 0.39479, we get 3.15832 and so on. Okay, so we've worked out the arc length of this sector here, the arc length of the other sector. Okay, so all that's left to work out in finding the perimeter of the shaded region is this length here, DE, the straight part here. So because we have a right angle triangle and we know the length of this side in the triangle, also the hypotenuse, we can use Pythagoras' theorem to work out the length of BD. Okay, if we have the length of BD and we subtract the length of the radius here in the larger circle, it will leave us with the length DE, which we need to work out the perimeter, okay? So using Pythagoras' theorem to work out the length BD, so one of the shorter sides in the right angled triangle, I have to square root the hypotenuse squared, so 13 squared, minus the shorter side here, 5 squared, and when I do that, I get 12 centimeters, okay? So this entire length here is 12. we know that the radius of the larger circle is 8. So if I minus 8 from 12, it will leave me with DE, which is 4 centimeters. Okay, so now we have all the edges of the shaded region. We can add them all together to work out the perimeter. Okay, so let's start with the length DE, so 4 centimeters. Then I'm going to add the arc length from the first sector, so 5.88. And then I'm going to add the arc length of the sector in the large circle, so 3.158. And when you add those three edges together, you should find that you get 13 centimeters. In the second part of this question, we have to work out the area of the shaded region. So to work out the area, I'm going to work out the area of this triangle, and then I'm going to subtract the area of these two sectors here, okay, as that will leave me with the area of the shaded region. So if I start by working out the area of this triangle, I'm just going to use the formula base times height divided by 2. So 5 times 12 divided by 2. Then if I work out the area of this sector here in the smaller circle, I'm going to use this formula below. Area of a sector equals a half r squared theta. Okay, so to work out the area of a sector, you multiply a half with the radius squared and you multiply by the angle theta of the sector, making sure that it's measured in radians. Okay, so we already have the angles of the two sectors. We worked them out earlier when we did the perimeter. Okay, so remember you're subtracting the area of this sector. So I'm going to minus a half, multiply by the radius squared, so 5 squared, multiplied by the angle theta 1, which we worked out here, which is 1.176. Okay, then we have to subtract the other sector from the larger circle here. So I'm going to minus a half, multiply that by the radius squared, so 8 squared, and again multiply by the angle of that sector, which we worked out here, 0.3947. Okay, so if you calculate that, the area of the triangle minus the area of those two sectors, it gives you 2.67, okay, and remember it's area, so it's centimeters squared. In the first part of this question, it says that theta is equal to a 6 pi, and we have to find the exact area of BCD in terms of r. So we have to work out the exact area of BCD, which is this shape here. Okay, so to work out the area of this shape, I'm going to work out the area of the entire sector, and then I'm going to subtract the area of this triangle, as that will leave me with the area BCD. Okay, so I've written down two formulae that I'm going to use in this question. Area of a sector equals a half r squared theta, and area of a triangle equals a half AB sine C. Okay, so let's start by working out the area of our sector. So to work that out, you have to multiply a half by the radius squared. And in this question, the radius is just r, so you're just going to leave it as r squared. And then you times it with theta, which is the angle, and they tell us that the angle theta is equal to a 6 pi. Okay, so if you multiply those together, that will give you the area of the sector. But now I'm going to subtract the area of the triangle, okay? As when I do that subtraction, it will give me the area BCD, okay? So to work out the area of this triangle using a half AB sine C, I need to know the angle, okay? So I've got the angle theta, which is C, and I need to know the length of these two sides, either side of the angle. Okay, so I have the side here R, okay, but I don't know the length of this side AD. Okay, but we can work out the length of this side in terms of r. Okay, we have a right angle triangle. This length AD is the side that's adjacent to the angle. Okay, and this length here is the hypotenuse. So if we're using the adjacent and the hypotenuse in a right angled triangle, we know that cos of the angle, so cos theta or cos pi over 6, is equal to the adjacent length over the hypotenuse. And remember, the hypotenuse is r, okay? From here, we can rearrange this equation to make a the subject, to find an expression for the length AD, okay, in terms of r. So I'm going to multiply both sides of the equation by r. So r cos pi over 6 is equal to the adjacent side, okay? So this length here is equal to r cos pi over 6. Okay, so now using that expression, I can work out the area to the triangle. Okay, so area of a triangle, a half AB sine C, is going to be a half times this length here, r, times the other length adjacent to the angle, so r cos pi over 6, multiplied by sine of the angle in between those lengths, so sine pi over 6. And that is how you would work out the area to the triangle, okay? So now we just have to simplify this to work out the exact area. So if I multiply these terms together here, I get r squared pi over 12. Then if we work out what this comes to, so cos pi over 6 is equal to root 3 over 2, and sine pi over 6 is equal to a half. So if we times a half by r, then by root 3 over 2 by a half, we should get, the denominator is 8, r times r is r squared, and have I missed anything out? No? Oh, root 3. Okay, there we go. Okay, and that's it. Okay, so that is the exact area of BCD. In the second part of this question, it says, given instead that the length of BD is root 3 over 2r, find the exact perimeter of BCD in terms of r. Okay, so we have to work out the perimeter of BCD, this part here, okay? So to work out the perimeter, you have to add all of the edges together. So we have this straight edge given already. We have to work out the length CD and also the arc length of the sector. And when we add those three edges together, that will give us the perimeter, okay? So let's have a look at the arc length to start with, okay? So the formula to calculate the arc length of a sector is here, r theta. So you have to multiply the radius with the angle of the sector. And we don't know the angle of the sector in part B of this question, okay? So we have to try and work that out first. So I can see there's a right angle triangle here, and I know these two lengths, okay, in terms of r. I'm going to try and use these two lengths to work out the value of theta, okay, the angle. So I can see this length here is opposite the angle theta, and this length here is the hypotenuse. So if I'm given the opposite and the hypotenuse in a right angle triangle, I know that sine of that angle, so sine theta, is equal to the opposite length, so root 3 over 2r, divided by the hypotenuse, which is r. I can then cancel this equation here. I can simplify. R divided by r is just 1, okay? So I'm left with sine theta is equal to root 3 over 2. From here, I can solve the equation for theta, okay? To work out the value of theta, so the angle of the sector, you would put into your calculator sine minus 1 of root 3 over 2, and you should find that you get a third pi, okay? So that is the angle of the sector in radians, okay? So I'm just going to write that onto the diagram here. Okay, so now that we've got the angle theta, we can work out the arc length, CB, okay? So if I work out the arc length, I'm using that formula from earlier, the radius, which is just r in this question, multiplied by the angle theta, which we just worked out here, pi over 3. Okay, so if you just want to simplify it, it's just r pi over 3, okay? So we've worked out the arc length, CB, okay? So all that's left to work out is this little distance here, CD, okay? So I can work out this length, CD, by taking the radius, so the entire length here, and subtracting the length AD, okay? That will leave me with this little bit here. So I'm going to use that method that I used earlier to write down the length AD in terms of r. Okay, so if I just call this x for the moment, okay, I can see that this length ADX is adjacent to the angle theta, okay? I also know that this is the hypotenuse of the right angle triangle. So if I use the adjacent side and the hypotenuse, I know that cos of the angle, so cos of a third pi, is equal to the adjacent side, so x, divided by the hypotenuse r. Then I can rearrange this equation to make x the subject. So I'm going to multiply both sides by r, so that r cos a third pi is equal to x. Okay, so instead of calling the length ADX, I can replace it with r cos pi over 3. Okay, so now we can work out the length CD, this little bit here that we need to work out the perimeter, by taking the radius, so the entire length here, and subtracting the length AD that we just worked out. Okay, so now we have all of the edges of the shape BCD that we can add together to work out the perimeter. Okay, so to work out the perimeter, we have the length that they gave us at the start, BD, so this is root 3 over 2r. Then we can add on the arc length, CB, that we worked out here, r pi over 3. And then we need to add the length CD, so this part down here, so I'm going to add r minus r cos pi over 3. Okay, so now we just have to simplify this. You can actually work this out. Cos a third pi is equal to a half. Okay, so this is going to simplify to root 3 over 2r plus r pi over 3 plus r minus a half r. Okay, so you can simplify these two terms at the end. If you have one r and you take away a half r, you're left with a half r. Okay, so the final answer, the perimeter to the shape, is here. In part A, it says find the angle BOC. So the angle BOC is this entire angle here within the sector, okay? We've been given the arc length for this little sector here, okay? The arc length is 2 centimeters. We also know the radius of the sector is 10, okay? So using this information with the formula arc length of a sector is equal to r theta, we can work out this angle here for the sector at the top, okay? Once we have that angle, we can add it to a 6 pi that's already been given in the question, and that will give us the angle BOC, okay? So using this sector at the top, the arc length is equal to 2. And remember, arc length is equal to the radius, which is 10, multiplied by the angle theta, which we're trying to work out. So if we solve this equation to find theta, we have to divide by 10 on both sides, so theta is equal to a fifth, or 0.2, okay? So this angle up here for this sector is a fifth. So if we want to write down the angle BOC, we need to add 1/5 that we just worked out to the angle here that was given at the beginning, a 6 pi. So in part B, we have to find the area of the shaded region, BPC, giving the answer correct to 3 significant figures. Okay, so we're trying to work out the area of this region here. So to work out this area, I'm going to work out the area of the sector of the circle, and then I'm going to subtract the area of this triangle, okay, and that will leave me with the area of the shaded part. So I've written down 2 formulae that I'm going to use. Area of a sector, which is equal to a half r squared theta, and area of a triangle, a half AB sine C. So let's start by working out the area of this sector of a circle. Okay, so to do that, we have to multiply a half by the radius squared, and the radius in this question is 10 centimeters, so a half times 10 squared. And then we have to multiply it by the angle theta in radians, and the angle is BOC. It's the angle that we worked out earlier in part A. Okay, so we have to multiply by a fifth plus a sixth pi. Okay, so that is how you work out the area of the sector. Okay, so next we have to try and work out the area of this triangle that we then need to subtract from this sector, which will leave us with the shaded part. Okay, so to work out the area of this triangle, I'm going to use a half AB sine C. Okay, so I can see that I already have this length here, so one of the sides in the triangle. I also have the angle theta we worked out in part A. So now I want to work out the length OP. Okay, so to do that, I'm going to look at the right angle triangle. I know that this length is adjacent to the angle, okay, and this length here, 10 centimeters, is what we call the hypotenuse of the triangle. So if we have the adjacent side and the hypotenuse side, I know that cos of the angle, so a fifth plus a sixth pi, so cos of the angle, is equal to the adjacent, so the one we're trying to work out, divided by the hypotenuse, which is 10. So now I can rearrange this equation to make A the subject, okay? So I'm going to multiply both sides of this equation by 10, so that 10 cos of the angle theta, so a fifth plus a sixth pi, is equal to A. So this length here, OP, the base of the triangle, is equal to 10 cos a fifth plus a sixth pi. Okay, so now that we've got that length here, we can work out the area of this triangle. Okay, and remember, we're subtracting the area of the triangle from this area of the sector from earlier. Okay, so area of a triangle is a half multiplied by A multiplied by B, so they're just the sides, either side of the angle that we're using. So 10 multiplied by 10 cos a fifth plus a sixth pi, multiplied by sine C, so that's just sine of the angle in between those sides. Okay, so again, a fifth plus a sixth pi. Okay, so when you put all of this into the calculator, this will give you the area of the shaded region, and if you round it to 3 significant figures, you should find at the end it comes to 11.4. And remember, the units for area are always going to be centimeters squared. So in part A, we have to find the perimeter of the shaded region. So we need to work out the perimeter of this region here. We've been given this length here, which is 6 centimeters, okay? So we need to work out the length of BD and also the arc length of this sector. Then we can add the 3 lengths together to work out the perimeter. So before we can work out the arc length of a sector, we need to know the radius and also the angle of the sector. Okay, so let's see if we can start by working out the angle of the sector here. Let's call it theta. Okay, we know that this triangle that's been given is an isosceles triangle. Okay, it has 2 equal sides here, and these 2 angles here at the base are also the same. So if we want to work out what one of these angles is equal to, we need to take the sum of angles in a triangle, so 180 degrees, or if we're working with radians, pi. And then we have to subtract the angle that's been given here, 1.8, and divide by 2. Okay, so that is how we would work out one of the angles here, theta. Next, if we want to work out the radius, okay, so this length along here, AC, what you can do is just cut this isosceles triangle in half so that you can see there's a right angle triangle. Okay, let's look on the right hand side, this right angle triangle here. We have the hypotenuse, 6. We also know this angle here, theta, or this angle here, half of 1.8, which is 0.9 radians. And from here, we can work out the base of the triangle x. Once we work out the length of x, we can multiply it by 2, which will give us the radius of the sector. Okay, so looking at this right angle triangle, I'm just going to draw it down here again so it's a bit clearer. So this angle we said was 0.9 radians. This is the base we're trying to work out, and the hypotenuse is 6 centimeters. So if we're trying to work out the opposite, and we've been given the hypotenuse, we know that sine of the angle, so 0.9, is equal to the opposite, which is x, over the hypotenuse, which is 6. So if you're solving this equation to find x, you need to multiply both sides of the equation by 6. So x is equal to 6 sine 0.9. Okay, and if you want to work that out in the calculator, you should get 4.69996 and so on. Okay, so this is in radians, my calculator. Okay, so next, what we have to do is take the value of x, 4.6996, and multiply it by 2. Okay, because that is how we will work out the radius. We only worked out half of the radius here, so now we're timesing it by 2 to work out the entire length. Okay, so with your answer 4.699996 and so on, you're going to times by 2, and that gives you 9.39992 and so on. Okay, so this is the radius of the sector. So now that we've got the angle of the sector and the radius of the sector, we can calculate the arc length. Remember, arc length of a sector is the radius multiplied by the angle, okay? And then we will be given the length CD, okay? So next, that's what we're going to do. Okay, so the radius is here, 9.3999 and so on, times by the angle theta, which was at the top here, pi take away 1.8 divided by 2. Okay, so when we do that, we should find that it comes to 6.3054 and so on. Okay, so this is the arc length. So we have the arc length, this one here, CD. We also have this length here, which is 6. So all that's left now is to work out the length BD. Okay, so this isn't too difficult because we just worked out the length of the radius. So we know this length here, okay, because this is also the radius, it's the same. So if this entire length here is also 9.3999 and so on, all you have to do is subtract 6 and you'll be left with this value here. Let's call it y. Okay, so to work out the value of y, you would take the radius, so 9.399 and so on, and subtract 6. Okay, so when you do that, you get 3.399 and so on. Okay, so now we have to add the 3 edges together to work out the perimeter. Okay, so we've got our value of y here, 3.399 and so on. Then we have to add 6 centimeters, and then we have to add the arc length here, 6.305. Okay, so when you put all of that into the calculator and round to 3 significant figures, you should hopefully find it comes to 15.7 centimeters. So in part B, we have to work out the area of the shaded region. Okay, so the area of this region here. So to do that, I'm going to work out the area of the sector, and then I'm going to subtract the area of the triangle, as that will leave me with the area of the shaded region. Okay, so I'm going to use this formula here, okay, to work out the area of the sector. So to work out the area of this sector, we have to multiply a half with the radius squared, and we worked out the radius at the beginning. Okay, remember the radius was 9.3999 and so on. Okay, so I have to multiply by that number squared. And then we have to multiply by the angle of the sector. Okay, and the angle of the sector theta, we wrote down at the beginning, it was here, it was this angle here. So pi minus 1.8 over 2. Okay, so this will give you the area of the sector. Okay, so now we're going to subtract the area of the triangle here. Okay, so I'm going to use the formula a half AB sine C. Okay, so C is the angle 1.8 radians, okay, and A and B are the sides either side, 6 and 6. So it's a half multiplied by A, multiplied by B, multiplied by sine of the angle in between, so 1.8. Okay, so when you subtract the area of the triangle from the sector, you should find, when you round to 3 significant figures, you get 12.1. Okay, so that is the area of the shaded region.